Okay, Assalamu alaikum. So, welcome to lecture 4. So, can you guys hear me?
Yes, sir, we can.
Okay. Okay, so let's get started then. Today, we will continue very briefly with regular expression and then we'll move on to string similarity. And we will then talk about text representations in TF, IDF if we have time. And so that would be the agenda for for today. The text representations in TF-IDF are sparse representations, and they would then be used for applications like information retrieval and text classification. So this would be done before we move on to more expressive representations based on embeddings of textual content in lower dimensional spaces. So that's basically the agenda for today. So we were talking about regular expressions last time. And we said that regular expressions are a powerful way for text matching. So regular expression essentially is a string which is written in a specific way. You can say is a language by which you can specify a set of strings. And through this language, you can basically then find what you want to find in a large body of text. So regex is implemented in many languages, and I guess most of us would now be using Python and Python 3, for example. So regex is basically implemented in the module which is called RE module in Python. So this module has various functions that let you process regular expressions in Python. Okay, we had already talked about a number of ways in which you can use regular expressions in the previous lecture. So are there any questions on that before I move forward? So we had regular expressions that were defined by characters, and those characters were used in the literal sense. So the character would match with characters. And then there were also some special characters that have specific meanings. Those special characters would match with specific things as defined by those special characters. So we had talked about several of them. So for example, the question mark is an optional. The previous character would be matched. Uh, So the previous character is optional, either it occurs or does not occur. And then we have plus the previous character occurs one or more times. Then we have asterisk, the previous character occurs zero or more times. So the question mark and asterisk are somewhat similar in the sense that the previous character can occur zero times. But question mark maximum is one, asterisk maximum is as many as you like. So so this was the other character. And then we also have a wild card, the period. So the period character is a wild card which will match any character. Okay. So if you want to use any of these special characters in the literal sense, then you will have to use the escape sequence W. So if you want to match asterisk, then you have to give a asterisk here. So for example, if you want to match H and then uh, asterisk, let's say star. So what would this produce? So can anyone explain the matches that this would produce or the strings that this string would match? So of course, the first four characters are literals. AAH would definitely match. So वी हैव AAAH, ठीक है। उसके बाद बैक स्लैश एस्टेरिक है, सो दैट विल मैच एज अ लिटरल, ठीक है। And then you have asterisk, which means that the previous character, which was an asterisk, can occur 0. Yes. So, so the previous character can occur 0 or more times. So it could be like this. It could even be AAAH without an asterisk. So no asterisk. Because after the backslash asterisk, we have an asterisk, which means that we can have an asterisk that is, we may not have an asterisk. Okay. Of course, we also mentioned that when you use characters as disjunctions in square brackets, they will be used in a literal sense. So, for example, a minus z and let's say asterisk and period and plus. So this will match any character from A to Z. It will also match asterisk. It will also match period. It will also match uh, a plus. So within a square bracket, you do not need to escape that particular character. But in other places, you will have to do that because then it has a special meaning. And if you want to use it as literal, you have to escape it. So if you have disjunctions of more than one character, then we can use the pipe string as well. So, so for example, uh, you can have, let's say if you want to compare cup and cap. So this would match, let's say, cup of tea, for example, cap worn by a student. Okay, so it could match any of those. This is an OR operator, disjunction. But this OR is for a sequence of characters, and within those sequence, you can define other things as well. So, for example, you can have the and let's say A. So this will match either D, it will match the capital D, small a, big A. Okay. So all of these would be able to be matched. So within those strings, you can use any of the combinations that we have already talked about. Okay. Okay. Uh, there are some additional special characters that are special characters with backslashes that have specific meanings. Maybe I can show them from the slides. So the backslash D would match any digit. And the backslash capital D would not match any digit, 0 to 9. So in other words, you can write this in other ways as well. So for backslash small d, you can write it as square brackets 0 to 9. ठीक है. So in other words, and this is generally the case for any given regular expression, there might be more than one way of writing that regular expression. ठीक है. So you need to keep that in mind. So there may be more than one correct way of writing a regular expression, depending on your implementation. As you already know, a caret, if the caret is the first character in square bracket, this means disjunction. This means not. So all the characters that follow it, you will be applying a not to it. So not a 0, not a 1, not a 2, not a 3, or not a 9. The backslash W would match any letter. And within this, any letter, depending on implementation, it also includes the underscore. And letter could be lowercase, it could be uppercase. It will also match any digit as well. So backslash W would match digits, letters, as well as the underscore. And if you use capital W, then it is negation of all of this. It will not match any of these. So backslash S would match a white space. And a white space is a space as we know it in English, but white space can also be a carriage return. It could also be a line, new line character. It could even be a line feed. Of course, of course, if you want to just find a carriage, then that's backslash R, as you can. So backslash T is a tab character. Backslash F is a line feed. Backslash F and backslash R are less commonly used in digital text nowadays. ये older text में आपको मिलेंगे. Nowadays, you'll typically find backslash N, which is a new line uh, character. Of course, if you use the capital S, then it means that we are not looking for that particular character. Okay? And there may be other ways in which you can other escape sequences depending on your implementation. One particular other I just want to mention is backslash B. So this is basically a uh, you can say a word boundary, and it's not a character that uh, occupies space. So in other words, backslash B would be an end. So backslash B uh, would okay. What was the question again? Which word would return the first character? For which one? For backslash B?
फिर जो आपने बाकी सारी एग्जांपल्स दी थी पिछली स्लाइड के पर उसके अंदर सारे जो फर्स्ट मैचेस थे वो रिटर्न हो रहे थे सो इज दैट द केस जो आपने पढ़ाया अभी तक
This is somewhat implementation dependent, but that is usually the case, yes. जो भी आप regular expression लिखेंगे, it will always return the first match. ठीक है?
थैंक यू सर
So backslash P can be able to, you can use this to specify the end of a word. ठीक है? And end of any character that is defined by backslash W. So what was included in backslash w? If you remember from the slides, it was, for example, A to Z. It was capital A to capital Z. It was 0 to 9. It was the underscore character. Okay? And maybe one or two others depending on the implementation. So if after a sequence of such characters, another character occurs, backslash B would match. So this is a good way of finding boundaries of words. ठीक है? जैसे हम टोकनाइज करना चाह रहे हैं यूजिंग रेगुलर एक्सप्रेशंस, तो आप इसको यूज करके कर सकते हैं बैकस्लैश बी से. इट विल फाइंड यू द एंड ऑफ बाउंड्रीज ऑफ वर्ड्स, एंड दैट बाउंड्री कुड बी a punctuation like a comma or a apostrophe or some other character. Okay. वन अदर थिंग, एंकर्स हमने नहीं देखे थे, वो भी स्पेशल करेक्टर्स हैं. उनकी स्पेशल मतलब है, एंकर्स आर करेक्टर्स दैट आर यूज्ड आइदर एट द स्टार्ट ऑफ ए रेगुलर एक्सप्रेशन और एट द एंड ऑफ ए रेगुलर एक्सप्रेशन, and there are two of them. So caret, by the way, had another meaning. If you recall, when the caret was used inside square bracket, it meant negation or not. But when you use caret as the first character in a regular expression, then this means that we want a string that is the start of a sentence. It's the start of a new line. So, for example, uh, so let's say you have a regular expression caret. Uh, this class, for example. So this would only match if this class occurs at the start of a sentence. So if this class is not the start of a sentence, it will not match. So it will not match something like this. Uh, so 25 students in this class. It will not match this because this class is not the start of this sentence. इसको मैं lower case कर देता हूँ, ठीक है? So when you have a caret, it will try to match whatever occurs at the start of a sentence. And similarly, the for and you have the dollar symbol. ये and डॉलर नहीं है, डॉलर कहाँ से आता है? सॉरी, डॉलर सिंबल. ठीक है? So dollar symbol, so let's say the following, and then you have a dollar symbol. So this would match this exact sequence when it is the end of a sentence or end of a line, uh, as given in the following. So it will match this if it is the end of a sentence. ठीक है? So these are anchors. Okay. So let me move forward. Although I can give you examples here as well as ask you to do something, but I think this is kind of something that you have done already before, so I don't want to spend too much time. Uh, a few other things before we end up. We talked about parentheses. So parentheses are also special characters. So if you parentheses can be used for multiple things. So parentheses can be used for precedence ordering. So you can group things. So if you want to give greater precedence to this as opposed to something else. Okay? So parentheses can also be used for uh, capture groups. So capture groups in regular expressions means that you can essentially uh, use those groups later on in the same regular expression with a variable. So let's say आपके पास कुछ इस तरह की चीज थी. let's say, mm, Asim, Kareem, ठीक है? And then let's say, uh, let me add a space here. So it's my name, but I've put Asim and Kareem in capture groups. And then period, ठीक है? So we actually have the literal period, then a space, and then let's say Mr. Then again, let's say backslash period. Backslash 2 is a, let's say, professor. तो लेट्स से ये स्ट्रिंग है आपके पास. सो जो पहले दो पैरेंथेसिस ग्रुप्स बने हैं, आसिम एक ग्रुप है, करीम एक ग्रुप है. रेगुलर एक्सप्रेशन लुक्स एट द फर्स्ट ग्रुप विच इज द फर्स्ट पैरेंथेसिस आसिम, और उसको एक वेरिएबल दे देता है बैकस्लैश 1, एंड इट मूव्स फॉरवर्ड इन दैट वे. सेकंड वाले को बैकस्लैश 2 दे देगा. So this particular sequence would match Asim Kareem period. Mr. Kareem is a professor, not Mr. Asim, because I've used backslash 2 there. Okay, so in this way you can use, you can have variables in your you can have variables defined in your regular expression that depends on what has been captured previously. So इसको आप substitutions के लिए भी use कर सकते हैं. So for example, regex in Python you can use rb sub जो है, ये command is used for substitution. ठीक है, आपके पास पहला पैटर्न है और ये आपके पास पैटर्न 2 है. ठीक है, समथिंग लाइक दिस. एग्जैक्ट सिंटैक्स आई एम नॉट फॉलोइंग द एग्जैक्ट सिंटैक्स, आई एम जस्ट गिविंग द रफ. सो पैटर्न 1, सो पैटर्न 1 में लेट्स से आपने कोई आपने ग्रुप्स यूज किए, वो पैटर्न 2 में भी ग्रुप्स यूज कर सकते हैं. देन यू कैन यूज इट इन ए वे टू substitute things in your pattern 2. ठीक है, whatever you have captured in pattern 1 you can use it to substitute in pattern 2. So these are capture groups and they are quite powerful, especially for text processing. So, and of course, if you don't want to give a group in a sequence of groups a variable, तो उसका भी एक तरीका होता है. So basically, मेरे ख्याल से I think asterisk after the first parenthesis or the parenthesis that you don't want to capture, you can add this. ठीक है, सो अब ये करीम को वेरिएबल बैकस्लैश 1 मिलेगा, आसिम को वेरिएबल बैकस्लैश 1 नहीं मिलेगा. तो फर्स्ट वेरिएबल वुड बी बैकस्लैश करीम. ठीक है, सो capture groups, as we are discussing right now, anything that you enclose in parentheses would be given a variable by your implementation, and the variable number would start from left to right. The first parenthesis, whatever is found within that, will be given the variable बैकस्लैश 1. The second group, as defined by the two parentheses, would be given variable 2 and 3 and so on. You can use these variables again in your regular expression, as I gave in the first example here. So this first asim, which is literal, of course, we are not using any additional regex operators within this. So asim, whenever it is found in text, would be given the variable बैकस्लैश 1. And this would be given the variable बैकस्लैश 2. So you can use these variables in your regular expression as I used it in this same expression. So backslash 2 would match, should match with Kareem. So if there is a Kareem here, then this would match. If there is Asim or some other word, it would not match. Okay? So this, so if you put a question mark and a colon after a opening parenthesis, that group would not be given a variable. So in this case, this was the first group. So this group would not get backslash 1. The second one would get backslash 1. And similarly, if you have multiple groups, जहां भी आपने कोई भी ओपनिंग पैरेंथेसिस के बाद क्वेश्चन मार्क एंड कोलन डाल दिया तो उसको वो उस सीक्वेंस में नंबरिंग नहीं करेगा. ठीक है. So again, this is greater control for you in managing your regular expressions as well as string matches. And finally, there's one other thing which I think I will probably skip in class, वो आप out of class भी देख सकते हैं, which is look ahead assertions. So this is also quite powerful. Basically, this controls the movement of your uh, position in the string. So depending on whether the assertion, of course, whether the assertion is true or false, your operator, your position in the string remains the same. So that आगे जब आप string regular expression के string को पढ़ते हैं वो वहीं से शुरू होता है. So there is an example in the slides as well. So I think we'll probably quickly go over it.
अस्सलाम वालेकुम सर। सर अगर एक सेंटेंस में मल्टीपल टाइम्स आसिम आया तो वो सबको बैक स्लैश वन असाइन कर देगा।
Multiple times क्या आया?
मल्टीपल टाइम्स आसिम आया हुआ है तो वो सबको बैक स्लैश वन असाइन कर देगा कि वो बैक स्लैश थ्री या फोर उसको असाइन करेगा, डिपेंडिंग ऑन द पोजीशन कि कौन सी पोजीशन पे वो है।
It depends on your regular expression actually. रिमेंबर जब हमने पहले आपने किसी ने क्वेश्चन पूछा था कि रेगुलर एक्सप्रेशन क्या रिटर्न करता है, जो फर्स्ट मैचेस रिटर्न करेगा उसके बाद आगे नहीं जाएगा. ठीक है. सो जब
ओके।
सो ये जो जो आपके रेगुलर एक्सप्रेशन में जो आसिम आ रहा है और जो आपके स्ट्रिंग में आसिम जब पहली दफा आएगा उसी को वो बैक स्लैश वन देगा. ठीक है. It may be possible that asim occurs at multiple positions in your string. You'll have to run the regular expression again. ठीक है. वो फिर नेक्स्ट वाला ढूंढ देगा in most implementations.
थैंक यू सर।
ठीक है. So the assertion, there are two look ahead assertions. Again, this is also as part of parenthesis. So parenthesis can be used in multiple ways. The first one, so the first way that I mentioned earlier was just for precedence ordering. The second one was capture groups that were assigned variables. And this third case is for look ahead assertion. Okay. So parenthesis के बाद question mark and then equal. And then whatever pattern you have after that. So if this pattern matches then this assertion becomes true, and we'll, we will look at the regex that follows this. Otherwise, we will not look at the regex that follows this. And similarly, if you have backslash, opening parenthesis, question mark, and an exclamation, this would be true only if the pattern does not match. And जब भी ये assertion true होगी, फिर ये हम regular expression के अगले part पे जाएंगे, otherwise हम इधर ही रहेंगे, पीछे ही रहेंगे. ठीक है? That's one thing. The second thing is, जब भी ये look ahead assertion वाला आप use कर रहे हैं, आपका pointer वहीं रहेगा, पीछे ही रहेगा, even if there is a match. ठीक है? So let's say जो pattern आपके पास था, आगे वैसे example भी इसमें दी हुई है. ठीक है? So square bracket में capital T और small t दिया हुआ है, and we are using question mark and exclamation. ठीक है? And after this group we have backslash w, मतलब words हैं, characters that form words. So this would only be true when the first character is not a t or a t. ठीक है? जब उसको first character not a tree and t मिलता है, assertion true होगी, तो फिर आगे जाएंगे, backslash w पढ़ेंगे. जब उसको पहला करेक्टर टी या टी नहीं मिलता, बैकस्लैश डब्ल्यू पढ़ेंगे ही नहीं हम. ठीक है? सो वी विल move forward only when this assertion is true in the regular expression. But in both cases, whether this was true or false, आपका पॉइंटर इधर ही रहेगा. So in other words, ये जो इस केस में लेट्स से आपका कोई सो बेसिकली जो भी वर्ड होगा जो टी और टी से नहीं स्टार्ट हो रहा, वो सारा स्टार्ट से ही आपको बैकस्लैश डब्ल्यू देगा. सो बैकस्लैश डब्ल्यू जो है वो स्टार्ट से शुरू होगा, not after this. So I hope this word is clear. Let me try to explain it another way. So let's say assertion आपकी true हो जाती है for उसी एग्जाम्पल की हम बात करते हैं. मेरे पास एक सेंटेंस है this day. ठीक है? this day पे ये assertion true नहीं होगी because not पे true होती है. ठीक है ना? So this day पे ये assertion true नहीं होगी. इसका मतलब है कि we will not match with this. ठीक है? And we will not be returning anything because अगला जो पार्ट बैकस्लैश डब्ल्यू है वो नहीं पढ़ेंगे. ठीक है? But let's say we have another sentence one day, ये हम पढ़ लेंगे. So because assertion has become true, and उसके बाद आगे हमारे पास क्या था, बैकस्लैश डब्ल्यू था. अब बैकस्लैश डब्ल्यू would start right from one. It will start from O and E. ठीक है? So it will return O and E. ऑफ कोर्स उसके बाद हमने बैकस्लैश बी बाउंड्री लगाई हुई है, तो ओ एन ई सिर्फ रिटर्न होगा. ठीक है? सो इफ वी विल नॉट मूव द पॉइंटर फॉरवर्ड कि वन हमने देख लिया हम आगे चले गए, तो इट काइंड ऑफ रिटेन्स द पॉइंटर इन द स्ट्रिंग एट द स्टार्ट. सो इन सम केसेस यू विल लाइक टू यूज दिस एज वेल. सो इन अदर केसेस यू मे नॉट. सो सिंपल आपके रेगुलर एक्सप्रेशंस भी चल जाते हैं. सो लुक अहेड असर्शंस भी इन सम केसेस यूजफुल होती हैं. वन फाइनल नोट बिफोर आई कंक्लूड. अभी जितनी भी एग्जांपल्स हमने देखी हैं, दैट वाज इन एस्की और इन स्टैंडर्ड इंग्लिश. यूनिकोड पे भी रेगुलर एक्सप्रेशंस चलता है. एंड इफ यू टॉक अबाउट पाइथन 3 एंड जो मैंने आरी मॉड्यूल की बात की थी, उसमें यूनिकोड सपोर्ट है. सो मोस्ट ऑफ व्हाट वी कवर्ड ऑलरेडी वुड वर्क एज इट इज इन यूनिकोड. लेट्स से आपके पास करेक्टर फ्रेंच का लेट्स से ई है विद वो जो थोड़ा सा क्रिटिक होता है उसके ऊपर, वो आपने एग्जैक्ट स्ट्रिंग में लिखा हुआ है, तो वो एग्जैक्ट उसी के साथ मैच होगा. ठीक है? एंड लेट्स से को आपका उर्दू का कोई करेक्टर अलिफ है तो अलिफ के साथ ही मैच होगा, वो लेट्स से आपने उसको स्ट्रिंग में लिख दिया तो उसी के साथ मैच होगा. बट फॉर यूनिकोड देयर आर सम एडिशनल कंट्रोल्स विच अगेन इज इम्प्लीमेंटेशन डिपेंडेंट, जो आपको फिर देखना पड़ेगा कि इम्प्लीमेंटेशन क्या दे रही है. मे बी यू वांट टू फाइंड जस्ट फाइंड ओनली characters belonging to a specific character set, तो उसके आपके पास कैटेगरीज डिफाइन कर सकते हैं आप. तो ये भी आपके पास कंट्रोल होता है इन सम इम्प्लीमेंटेशंस. सो ऑफ कोर्स ये थोड़ा बहुत वेरी करता है, इट्स काइंड ऑफ कैन गेट कॉम्प्लिकेटेड. तो जब भी आपको जरूरत पड़ेगी यू हैव टू लुक एट द हेल्प of that particular module or API and then see how it can be used. So Unicode के लिए you need to pay a bit more attention, and most modern day NLP applications do involve Unicode because we are typically dealing with multilingual text. Multilinguality is now almost universal. तो आप assume नहीं कर सकते कि आपके पास सिर्फ इंग्लिश में टेक्स्ट मिलेगा, आपको टेक्स्ट मल्टी लैंग्वेज में मिलता है, एंड इट डज कॉज कॉम्प्लिकेशंस इन योर एप्लीकेशन. सो आपको पहले ही राइट अप फ्रंट में ही आपको ये इसको कैटर करना चाहिए. ओके, so that was a conclusion of regular expressions. All right. वहाँ पर 38 minutes गुजर गए. अच्छा, ठीक है. In the last class, I think I asked you about Urdu and BPE and basically tokenization. So can anyone update me on their findings? It was kind of a homework for you. Anyone? So byte pair encoding, if you use the byte level byte pair encoding, so it would be applicable to Urdu. But are there any caveats that we need to be aware of? And are there any better techniques that might be better for Urdu or Arabic or any other language for that matter? So anyone, किसी ने किसको देखा भी है? So any comments on this? Sure. So basically इस तरह के जो questions हैं, I might ask you once in a while. So I expect at least someone to respond, because थोड़ा पता time लगता है. I think hardly takes 5-10 minutes on Google search to find things out, and you should be doing such kind of work in your learning process, because जो class में हम पढ़ते हैं वो is probably not enough. You need to spend time outside class to learn about things. And I guess आजकल जो जीपीटी है या लामा है, वट एवर यू आर कंफर्टेबल विद, वो काफ़ी कुछ आपको बता देता है. एंड यू शुड यूज़ इट, वी आर नॉट डिस्करेजिंग इट, you should use it for your learning purposes. Uh, okay, just a few comments that on उसी के ऊपर no one is commenting on this. एक तो of course I commented last time कि in most multilingual corpora उर्दू का कंटेंट वो थोड़ा होगा. टिप किसी ने कोई कमेंट किया? आई डिडंट गेट इट. लेट मी सी. Okay, it's morphine based. So, okay, that's a good point. Anyone else? All right. So, okay. So, we mentioned last time, if उर्दू कंटेंट जब थोड़ा होगा तो उर्दू की लॉन्गर स्ट्रिंग्स नहीं मिलेंगे और टोकन्स नहीं मिलेंगे, because it will be dominated by it will be probably dominated by English. So there are two general ways of avoiding this. One, and I think both of them have been mentioned by people here. The first one is morpheme based, and is uh, this is fine, but again, finding morphemes is relatively difficult. Urdu mein, you might have a morpheme dictionary, and you might start with your initial tokens to be these morphemes. उसके बाद आप BPE लगा लें, ठीक है? So start with tokens that are morphemes, and morphemes ki maybe dictionary I think available. Urdu ki morphemes it's quite complicated. By the way, Urdu is a morphologically rich language. It's much more complex as compared to English. So Urdu is a morphological rich language. Arabic is even more, I would say. And I'm not too familiar with Farsi. And of course, I don't know anything about Chinese. आपकी स्लाइड्स में एंड ऑफ कोर्स ऑन द टेक्स्ट बुक चाइनीज का जिक्र काफ़ी है, फॉर दोज हु नो चाइनीज तो वो उसको फॉलो अप कर सकते हैं. ऑब्वियसली चाइनीज इज नाउ ए मोर मेन स्ट्रीम लैंग्वेज, एंड वो लैंग्वेज सीखनी चाहिए, किसी को आती है तो आई थिंक वेल एंड गुड, बट आई डोंट नो एनीथिंग अबाउट चाइनीज. ठीक है, सो वन आइडिया इज ब्रेक डाउन इनटू मॉर्फीम्स एंड देन अप्लाई योर बीपीए एल्गोरिथम. The other idea is maybe just start with characters, but then uh, use language modeling, and in particular use the technique that's called unigram language modeling tokenizer. So this would probably give you better results, because for each word it will find those subgroups that maximizes the probability of that word. So इसको मैं इंग्लिश में एक्सप्लेन करने की कोशिश करता हूँ. So let's say मेरे पास वर्ड है अनब्रेकेबल, ठीक है? इसमें अनब्रेकेबल की प्रोबेबिलिटी जो ऑफ कोर्स लैंग्वेज मॉडलिंग में हम स्टडी करेंगे, यू है, लेट्स से एन है, ब्रेक है, लेट्स से ए बी है और एल ई है. आप इस तरह भी प्रोबेबिलिटी इसको लिख सकते हैं. आप इसको इस तरह भी लिख सकते हैं, यू एन ब्रेक और एबल भी लिख सकते हैं. आप ऑल करेक्टर्स भी लिख सकते हैं, यू एन बी आर ई ए के ए बी एल, ठीक है? So we will use that tokenization that maximizes these probability. कौन सी probability सबसे ज्यादा है, वो tokenization use करेंगे. तो unigram language model encodes, remember there are two phases, training phase और encoding phase है. encoding phase में ये इस तरह probabilities निकालता है हर word की and its sub components, और जिस combination of sub components की probability सबसे ज्यादा आती है तो वो tokenization best है. तो उर्दू के लिए ये बेहतर काम करेगी. एंड ऑफ कोर्स दूसरा तरीका ये है कि मॉर्फीम्स से स्टार्ट करें एंड देन बिल्ड अप योर वोकैबुलरी फ्रॉम देयर. ठीक है, एनी अदर कमेंट ऑन दिस? ऑलराइट, okay, so now let's move on to string similarity. So far we have talked about string matching. So regex is for string matching, and also it can be used, using that matching you can use it for many applications, simple applications. But we also sometimes two strings would not match exactly. So we need to way of quantifying their similarity. And here we are talking about string. Okay, so there is a question on finding these probabilities may not be very efficient. So that's right. So unigram LM tokenizer is less efficient as compared to BPE. Uh, but uh, but as you already know, because nowadays we have these large language models, and they typically can encode huge amounts of data. So you can get these probabilities from there as well. So, and of course, ये जो computational cost है, one time है, आपने शुरू में ही करनी है, उसके बाद नहीं करनी. So maybe for the long run, for an application, it may not be a big deal. So ठीक है, वो expensive होगा as compared to BPE, but for specific applications, it may not be a big deal because just has to be done once. ठीक है? Okay. So we are coming back to string similarity. So if two things don't match, so we would like to know how much that they match. So that's similarity. So what is the similarity between two strings x and y? Okay. And we have to quantify this, let's say between 0 and 1, or alternatively, we want to find the distance between strings x and y. Okay. So similarity and distance, you can swap one with the other. Okay. So so how many of you know about the Hamming distance? Hamming distance आपने कहीं पढ़ा है किसी कोर्स में, maybe in the networks course? अच्छा, Hamming distance. अच्छा, ठीक है. So general sentiment ये है कि ये नहीं आपने का नाम सुना. So Hamming distance is simply the number of switches that you need to translate one string to the other. But इसमें condition ये है कि both strings should be of same length. So for example, आपके पास then है, and let's say uh, कौन सी एग्जांपल लेते हैं? ओके, ठीक है. then and then. ठीक है. So both strings are of length 4. The Hamming distance would compare each string one by one. So T and T, so there's a match. H and H, there's a match. E and E, there's a match. N and M, there's no match, so it counts as 1. So number of swaps that are required to translate one string into the other. But we go character by character. And since both strings are of the same length, so we don't have an issue. ठीक है? But what happens if both strings are of different length? Then, let's say, or let's say 10. इस पे आप Hamming distance तो नहीं लगा सकेंगे, because Hamming distance does not define uh, other than swaps. ठीक है? Okay. I didn't understand your question, but same length के ऊपर कोई question था आपका? So, okay. So then and 10. So this is not of the same length. So you cannot apply Hamming here. So in this case, in general, what we will like to do is we'll find or so number of insertions, deletions, and substitutions to uh, move from first to second string. Okay, but इसमें obviously you will have to do an alignment. ठीक है? So alignment, for example, क्या होगी? Let's say T एच ई एन है, तो टी इधर आ गया, ठीक है, टी के साथ। तो एच के नीचे यू प्रॉब्ली हैव टू पुट एन एस्टेरिक and then E and then N. So TT, of course, there is no substitution, ठीक है? So there is no cost. Then H and asterisks, H delete हो रहा है. So there's a deletion cost which is 1. And then of course E and E कुछ नहीं हो रहा है, N and N कुछ नहीं हो रहा. So this would be a cost of 1. So this uh, problem of finding string similarity between strings that are not of the same length is called the minimum added distance. So number of edits that are required, the minimum number of edits that are required to move from one string to the other string. And for each edit, there's a cost associated with it. Okay? And we sum up all those costs. So that cost would be our minimum edit distance. ठीक है? अब इसमें एक और complexity भी है. I said it's the minimum number of edits to go from one string to the other. So let's say मैं ये करता हूँ, let's say मेरे पास पहला string था THEN,